Hello, my dear old crazy chemist. I hope you are all fine and enjoying our channel. At the moment, it's very difficult to get proper coaching because due to the COVID-19, we all know that we cannot move out from our house. So it's really difficult to get a good coaching in chemistry. So that's why I thought that why not we can start to learn by online mode using the YouTube channel. So basically in this video I have tried to give some introduction or the brief idea in the atomic state of different kind of molecules or the atomic model of the molecules, how the electrons are basically arranged in the atomic structure. So I split in different section of this video where you can learn how this different aspect of different atomic model works. So in this video you can see that it will give a brief idea about the quantum mechanics as well as the limitation of the Bohr's model. Not only that, but also you can learn the Hessenberg uncertainty principle, which is very useful to deal with the quantum mechanics, and finally you can learn what is the basic limitation of the Bohr's model. So you can follow with me and let's see what we can get from today's video. So don't forget to like, share and comment and subscribe our channel if you are visiting the first time of our channel. So that will inspire us to make more video, and comment us if you like this video. So let's see. Okay, all right. I hope now you can see the screen properly, and it's a given idea of the structure of atom. And I thought that why not I can put the scientist name who have a lot of discovery in this field. And you can see here the top was the Broglie, and then followed by Hessenberg and also the Schrödinger. And to give a brief idea and the atomic model, that's why I have put a small atomic system where you can see the nucleus is basically the neutron and proton, and the outermost shell, which is basically consist of electrons. So all right, next proceed for the next slide. So what are the content like in this topic? As I told you before that I split in different video, and I will go through in different section of this unit 2 of your CBSE or ISC course. And in this atomic model, in this video I will basically go through this content which are limitation of the Bohr atomic model, and next I'll say something about the quantum mechanical model, and there basically you will learn the dual behavior of the matter, and then the Heisenberg uncertainty principle as well. I will also discuss reason behind the failure of the Bohr model, and what are the postulates of the quantum mechanics, and why the Schrödinger equation is very famous. So yeah, the limitation of the Bohr atomic model theory, which is very important after the failure of the Bohr atomic model. Next Heisenberg and also Schrödinger give an idea for the quantum mechanical aspects. So what are the limitation of this model, and after this limitation, why quantum mechanics comes out to solve this problem, we'll go through in this video. So basically the Bohr's model, it violates the Heisenberg uncertainty principle. This uncertainty principle I'll discuss later in this video. The Bohr atomic model theory considered that the electrons have only known radius or the orbit, and at the same time the position and momentum of the electron is predictable. or you can know the momentum and position of the electron, which is basically impossible according to the Hessenberg theorem. Next, the Bohr's atomic model theory made for the prediction of the smaller size atom only basically for the hydrogen atom. So Bohr's theory only gives an idea for the hydrogen atom, but for the other kind of atoms like larger molecular atoms, it cannot be predicted. So what does it mean? The larger atomic model links that the after the hydrogen there are so many atoms or the molecules are basically present. If you consider like helium, magnesium, boron, carbon, so Bohr's atomic theory cannot give an idea of that kind of larger molecular structure or the atomic model. So it can only predict the hydrogen atomic systems. No other elemental or the atomic model is possible to analyzed by Bohr atomic theory. All right. So next is it failed to explain the Zimmermann effect and the spectral line, how it's split in several components when the magnetic field is applied. So I will also discuss what is the Zeeman effect and how the experiment was went through. But now for this Bohr's atomic model, you can consider that Bohr cannot give any explanation for the Zeeman effect and how it so went through when magnetic field is actually applied. It also failed to explain the Stark effect when the spectral line gets split in the presence of an electric field. Right? So next we move towards the quantum mechanical model of the atom. So after the shortcoming of the Bohr's model, it was a great attempt to make a developed of the atomic model, which are basically went through the quantum mechanical aspect. So these two pioneer scientists like de Broglie's, which gives the dual behavior of the matter, like here you can see de Broglie's dualism or dual behavior of the matter, and the Heisenberg uncertainty principle. These are the major contribution of the beginning of the quantum mechanics. These two scientists discovered their theorem, which is very important, and here we will also learn what are these. So first you can see the dual behavior of the matter. So French physicist de Broglie in 1924 he was discovered that the electron is not only behave as a particle, but it has both particle and wave-like property at the same time. And de Broglie's analogy gives that if an electron has a wavelength of lambda and it has a momentum p, then it gives like following equation where lambda is equal to h by mv, where h is the Planck constant and it's divided by the mass and volume by velocity of the particle. mv is considered as a momentum of the particle, that is h lambda equal to h by p. So this is very important for mathematical calculation, and later in the problem solving part I will discuss more about this equation. But right now you can only consider that the particle momentum, and which is very much important with the wavelength, right? So de Broglie's prediction confirmed experimentally that the electron has a dualism or wave particle property is considered in de Broglie's theorem. And by maintaining this theorem, it is very important to making the electron microscope when it's discovered. This basically goes through the de Broglie's theorem. So maintaining the de Broglie's theorem, electron microscope is basically discovered, which is based on the wave-like behavior of the electron. But for our normal microscope, the nature of the light, wave nature of the light is only considered. So next theorem is a Heisenberg uncertainty principle. So German physicist in 1927, he discovered the uncertainty principle of the matter in the radiation. So it states that it is basically impossible to determine simultaneously the exact position and exact momentum or the velocity of an electron. So what is actually says the exact position and momentum cannot be predicted simultaneously, or it is basically impossible, right? So mathematically he derives an equation where delta Ax multiplied by delta Px is greater than equal to h by 4 pi, and then he also says that delta P is written by mv as because of this is the momentum factor, right? So in this equation, we all know that it is very important. If the velocity of the electron is uncertain, then we can know only the position. So at the same time, we cannot predict the delta x when we know that delta p is predictable, right? So that's why here I have written something that the velocity of the electron will be uncertain if we know the high degree of accuracy of delta x. So if we know delta x, delta p cannot be predictable. If we know delta p, then delta x cannot be predictable at the same time, right? So this formula is also like mathematically established, and it has a big derivation that you will know if you have interest to study more, and then the higher class it will be explained mathematically how this derives. But right now for your consideration, like you should remember this formula for the mathematical calculation, like it can becomes out what are the velocity if we know the exact possible of accuracy of the position of the electron. Then you can calculate from here the mass and then the Planck's constant, and then you can calculate the velocity, right? So the Heisenberg uncertainty principle is basically nothing but the experimental phenomena you can see for macroscopic particle. It's very difficult to get meat of this idea, but for microscopic particle it is possible to predict this idea. Like you can say like when you can see in the microscope, if you try to exactly find out where is the electron in electron microscope, then you cannot predict the exact position. You can say why, because in electron microscope when you look at to find out the electron, then you need to pass some light through it, and light will collide with the electrons, right? And after the collision, the electrons get energized, and it has a next momentum, and it changes its momentum. So precisely you cannot tell what is the exact momentum in the exact position of the electron. So that's why the Heisenberg uncertainty principle says that it cannot be possible to predict at the same time the position and the momentum of an electron. And here I have also reported the photonic energy of the light in terms of the momentum, which is basically h by lambda. This is very important formula for the mathematical calculation. So what are the significance of the uncertainty principle? The effect of Heisenberg uncertainty principle is significant only for the motion of the microscopic object. It is negligible for that of the macroscopic object, right? Well, next in this slide, it says that reasons for the failure of the Bohr's model. The Bohr's model, an electron is only considered as an particle. Remember, the electron is only considered as a particle moving well-defined circular orbit about the nucleus. The wave character of the electron is not considered in the Bohr model. So, the wave and particle both character is considered in the quantum mechanical aspect, which is missing in the Bohr's model. Bohr's model only considered the particle behavior, but quantum mechanics gives particle as well as wave behavior. So quantum mechanics is well established findings of the atomic model. So this is the limitation of the Bohr's model, that it's only give an idea of the particle behavior of electron. Further, the orbit is a clearly defined path and completely defined path where it's possible to get the position and velocity at the same time. The Bohr's model is only predictable for the hydrogen atoms, therefore it not only ignores the dualism but also contradicts with the Heisenberg principle. So next solution is the quantum mechanical model, and here I have give a brief idea of the atomic model, like the electronic paths and its surrounding throughout the nucleus, right? So next is the quantum mechanical model of the atoms. So the classical mechanics based on the Newtonian law, such as falling of stone. The classical mechanics not only gives an idea about the particle behavior, only the particle behavior, but whereas the quantum mechanics gives particle and wave both behavior. So in quantum mechanics, it was Heisenberg and Schrödinger, both two pioneer scientists in 1926, discovered the quantum mechanical aspect of the atom. So the Schrödinger is give a equation where H psi is equal to E psi, where H is the mathematical operator called the Hamiltonian operator, and the Schrödinger equation, by solution of this equation, you can find different E1, E2, E3, like En, nth number of energy state of each electronic level. At the same time, you can also solve the psi function, and this solution basically gives different quantum number that will comes out in later. So in this formula, it is important to know H psi equal to E psi, and the solution of the E and psi gives different aspect of the atomic model. So next comes out the postulates of the quantum mechanics and the important features. The energy of the electrons in the atom are quantized exactly. Quantized means exactly fixed, right? And the second thing says the exact existence of the quantized electronic energy level is directly result with the wave-like property of electron and allowed the solution of Schrödinger wave equation. The third point, what it says, both exact position and exact velocity of the electron and atom cannot be determined simultaneously, which actually says by Heisenberg uncertainty principle. The fourth point of the quantum mechanics says an atomic orbital gives us a wave function that we have seen before, the Schrödinger equation, where psi is a function of the Hamiltonian equation, right? And this psi is the probability of finding electron of a point of the atom is proportional to the square of the orbital wave function. Later we will come, the solution of the psi function give different orbital aspect, and psi square is the probability density factor. Next, the hydrogen atom of the Schrödinger equation. When Schrödinger equation is solved for hydrogen atom, the solution gives the possible electronic energy level can occupy corresponding to the psi function. Like I have told you, E and psi to nth number you can solve, and you can get the different of the electronic energy level and the electronic system, right? So this quantized energy state corresponding to the wave function are characterized by a set of three quantum number. So the psi function and the energy state E gives, after the solution of psi and E, you can find different principal quantum number, azimuthal quantum number, and magnetic quantum number that I will told you later. So now you can understand what is the solution, solution of the psi function and how it's give different aspects after solution of the psi function. So what are the important formula of this video, of this unit? So here you can see lambda is equal to h by mv, and mv is replaced by momentum, which is called the p. And now you can get an idea, like if you know the momentum, then you can know the wavelength, after solution of this equation. And also you can learn from Heisenberg uncertainty principle. So this is the de Broglie's principle, and now this is the Heisenberg uncertainty principle, where it states that delta x, the position of the electron, and delta px, the momentum of an electron, is greater than or equal to h by 4 pi. So you can solve this equation and you can get the exact what you want to need. Like if you want to know the velocity, you can solve from here. You can know the momentum, you can solve this equation. If you know the position, you can solve this equation. And here I have written the Planck's constant value, right? So conclusion of this video, the Bohr atomic model is only based on the classical mechanics, on Newtonian mechanics, but it only applicable for the one atomic system or hydrogen-like system. It cannot predict the other atomic model or the higher mass number of the atomic system. The quantum mechanics electrons are not only considered as a particle, but it also gives a wave property, which is basically very important to predict the atomic system. The wave-particle dual character are nicely described by the de Broglie's theorem, and which is very important for the different mathematical solution. And precise position of the electron and momentum simultaneously unpredictable, which is very famous for Heisenberg uncertainty principle. And the Schrödinger equation is the new development of quantum mechanics, where you can see the H psi is equal to E psi, and you can solve the different energy state of the quantized different level, or you can say the different orbital level. What is the energy? You can solve this factor of energy, and you can solve the psi function, and you can get what are the different orbital levels. So Bohr's model provides the concept of principal quantum number, but there are other quantum number which is also reported that comes out from the solution of the psi function. Thank you for watching this video, and if you have any question, you can drop by this email ID. So I hope you can enjoy this video. So don't forget to like, share, and subscribe this channel. Thank you.